So I've got the date on my notes. Yes? You have your date on your notes. What else do you have at the top? Okay, what's our title? Okay, so this has been confusing people all day. I wrote operations with and compositions of functions. It's so I didn't have to write operations with functions and compositions of functions. But I'm going to write that so you're not confused. It's good though. It's all good. So we're going to start with operations. Okay? In math class, you understand I'm not talking about an appendectomy, right? When I'm talking about operations. What am I talking about in math class when I'm talking about operations with functions? Does anybody know the 4 major operations that we use in math? Add, subtract, multiply, divide. That's exactly right. Okay? So, can I backtrack a little bit? Okay? What does this mean? It means a function, right? We know it equals y for our level of math, but for us it very specifically tells us that whatever we write after this is a function, right? Okay? How do we find an inverse function? Okay, so let me ask it again. How do you find the inverse of a function? Switch x and y. Okay, I'm going to ask it one more time so everybody has a chance to answer. How do we find the inverse of a function? Excellent. Okay, so I'm going to tell you right now that f of x is 2x plus 5. And I'm going to tell you g of x is x minus 6. Okay? What does this even mean? G of x. So if I said, boy, can you help me by sharpening my pencil? Who am I talking to? There's several boys in here, aren't there? Okay? But I could also say, Justin, could you please sharpen my pencil? Would you know who I'm talking to then? Exactly, right? So I gave him a name. Well, guys, that's exactly what I did here. I gave it another name. This is F, and this is G. Okay? Now, if I say F and G really fast, understand I'm not cursing. I'm just saying F and G. Okay? But it changes the name of it. I can talk about multiple different functions, and you know exactly what I'm talking about because I gave it a different name. Okay? So how many different ones could I have? 26, right? I probably wouldn't do x of x because that would get confusing, right? So 25, but really, that's 50. Because something that really blew my mind when I was taking my graduate classes, when I was getting my master's, these two things are completely different. Lowercase and capital, different. Different. Okay? So I could talk about 50 functions. For the record, we're going to talk about like 2 or 3 at a time. That's it. Okay? What do you think the next one would be if I gave you one more? H. Yeah. Alphabetical, yeah, that whole thing, right? Okay? But for right now, we're just going to deal with these two, F and G. Is that what I want? Yes. Yep. So what do you want to do first? Which operation would you prefer to do first? Adding. Okay, we can do adding first. F of x plus g of x. What do you think I'll do? Okay, write down F and write down G and then add them like it says. Hey, do I need parentheses around this and around this? Not when I'm adding, right? I mean, I could put them, but then they would be obsolete in the next step, right? What do I do? What do I do now? What's the terms I need to combine here? Which is 3x and then 5 and negative 6, which is negative 1, right? Done. What? That's what it is, yeah. I don't make up stuff like that. Okay. Everybody okay?
I think everybody's confused on is that the answer?
Oh yes, that's the answer. Yeah, that's the answer. If I say f of x plus g of x, that's the answer, and we're done.
Oh, that's just the whole problem?
Kind of. Kind of. If I say I want to do an operation of functions, there's one more part that I'm going to ask you to that I'm going to require you to do as part of the answer, and that's write the domain. You'll always be given different functions and asked to either add, subtract, multiply, or divide them, and it'll tell you exactly what to do. Okay. Right now we're adding, so yeah, today. Yeah, for real. Okay, so I need the domain of this new function, though. So I need to think about this in my head. What shape is this new function? It would look like y equals 3x minus 1. What shape is that? A line. What's the domain of lines? All real? Yeah, that's it. What if it was a parabola? What would be the domain then? Oh yeah, all real. What if it was a cube cube function? All real. Okay. Now it changes when we have square root or, well, not cube root. That's all real, right? It changes sometimes, but most of them the domain is all real. You just have to think about what it is, and then tell me what the domain is. Some people said, oh, I don't know what that is. I'm going to put it in the calculator and graph it and look at it. Okay, that's great. It takes longer than just thinking about it, but you're still going to get to the right answer, right? Okay. Now, there is something that I want you to be aware of, but not panic about, because I know you. The problem won't necessarily always look like this. Sometimes it will look like this. It's the same thing. Same thing. This is saying f of x plus g of x, and this is saying f plus g of x. Yep. Always. I don't know. It's fine. I just agree with him sometimes, and that's okay. Yeah. We all looked up. I have no idea. I don't know what I did. It's okay. What's next? What's next? Subtraction, okay. F of x minus g of x. I'm waiting. If I ask you to add them, we get this as our answer, and then you write the domain, and then that's it. I wrote the green part right here to let you realize that sometimes the problem that it's asking you doesn't look like this, it looks like this. Nope, because it's right there. For a line, as long as it's not a vertical line. Yes, ma'am. Can I answer that later? Okay. Ask me. Oh, we haven't done subtraction yet, but we will. That is definitely foreshadowing. Yeah. All right. Can we do f of x minus g of x? What's wrong? Continue. Okay. Do we need parentheses this time? Because we're subtracting, right? We're subtracting the whole thing, so we definitely need to remember our parentheses this time. Does f need parentheses? No, not really. Okay. Yeah, we're using the same f and same g. Okay. Minus g of x, which is x minus 6. So I actually have another step before I can start writing the answer this time, don't I? I have 2x plus 5 minus x plus 6. Because remember I distributed that x here, or the negative here and here. Okay? Now I combine like terms again. X plus 11. I need my domain. I'm sorry for not saying this. This is the answer. Okay, this is the answer. Now I need my domain. What shape is this? It's a line, it's not a vertical line, so my domain is all real. All real numbers. X is allowed to be anything. Okay? All right, what do you want? Yes, ma'am. You just have to know. Can you give me one more example? Yes. No, I'm just saying, give me one more example, and then I think that'll help. Okay? What's next? Multiply? Okay. Oh, wait. Wait. Will this always look exactly like this? What might it look like? F minus g of x. Okay. So now multiply. F of x times g of x. What about parentheses this time? Are they important this time? Yeah, they're really important this time for both terms, right? So I just distribute, right? Okay, so 2x times x, 2x squared, 2x times negative 6, negative 12x, 5 times x, 5x, 5 times negative 6, negative 30. Combine like terms. 2x squared minus 7x minus 30. What shape is this? That's a parabola. How do you know it's a parabola? Because you have the squared, right? Neither one of these two have any sort of exponent or variable besides x. Okay? This one has an x squared. It's the highest exponent, so I know because of past experience that is a quadratic. It makes a parabola when I graph it. Parabola looks like this because it's a vertical parabola because it's y equals that, right? So what is its domain? How far left does it go and how far right does it go? Still all the way, right? And so the domain is still all real. Is that a little better? Well, it'll be the most better next. Okay? What else would this look like? What else the problem look like? Fg of x with no sign in between the two of them. Okay? Last one? Division. Oh, we're going to change it up though. Why are we going to change it up? I don't want you to think it's always F something, G something. Okay? It doesn't. We had to do G first. The order matters what's written there. You don't have to like it. That's how it is. So, G of x divided by f of x. What is G of x? X minus 6 divided by f of x. That's the answer. Yeah. Guys, there's nothing to simplify, is there? In fractions, the only thing we can simplify is common factors. All of these are simplified to their simplest form, so there's nothing to factor out. That's the answer. But let's talk about the domain now. If you have a fraction, which this is, what is the denominator not allowed to be? 0. The denominator cannot be 0, right? We can't divide by 0. Only one person that I know of can divide by 0, and Chuck Norris is not here. Okay? So we have to think to ourselves, what if it was 0? What makes this denominator equal to 0? So I say, I take the denominator and literally make it equal to 0. And then I solve this by subtracting 5 from both sides and dividing both sides by 2. So I see that x equals negative 5 halves. Is x allowed to equal negative 5 halves? No. Can x be anything else? It can literally be anything else except for negative 5 halves. So when I write my domain, I say it's allowed to be anything except for negative 5 halves. The domain is all real numbers except for negative 5 halves. X is not equal to negative 5 halves. Correct. Now the other way, do you remember how to write it the other way? In interval notation? Can I just remind you? It's been a long time since we've done it. It's been since the beginning of the year since we've done it. Negative infinity to negative 5 halves, union with negative 5 halves to positive infinity. There's no brackets because negative 5 halves is not included. I go all the way up to negative 5 halves and I stop and I start again on the other side of negative 5 halves and go on. Okay? What's the other way that division can look? So G over F of X. How are you feeling about operations with functions? Add, subtract, multiply, divide. Can you find the domain every time? Okay. Now composition. Okay. For the record, in math, when we're talking about composition of functions, we're not talking about writing an essay, just so you know. Okay, so you don't have to worry about that. Although you should all be able to write an essay, smarty pants. Rude. About anything I ask you to. Yes, ma'am. Was our domain always all real numbers? No. So you just have to think about what shape the answer makes and decide what the domain is from there. Okay? Composition of functions I'm going to approach slowly. We're going to do some slow steps before we get into it. Because there's stuff you already know, and if you can remember the stuff you already know, it's going to make composition of functions a lot simpler. Okay? So let's start here. F of x equals 7x minus 3. That's just me telling you that f of x is 7x minus 3. You okay with that? So what if I ask you for f of 2? What do I want you to do? Because what used to be here? An x. What did I put there now? 2. That means anywhere there's an x in the problem, I want you to put a 2. So 7 times 2 minus 3. What is 7 times 2? 14 minus 3? 11. That's the answer. You okay with that? So if you can remember that, we typically call that evaluating functions, right? We're putting a number in for the variable. So if you can remember that, a lot of the rest of this is going to be a lot easier. Okay? Because here's what composition of functions looks like. Okay? I'm going to tell you f of x is 2x minus 3. And I'm going to tell you g of x is x squared plus 5. All right? What I want from you is f of g of x. Did you hear how I read that? F of g of x. This was f of 2. And what did I do with the x? I put it with a 2, right? So if I'm wanting f of g of x, what do I put in instead of x? Time out. You're not wrong. I just want you to wait for a second. Is that fair? What do I want you to put in the problem instead of x? G of x. Okay? I understand that you figured out what we're doing, but not everybody has, so I need to go a little slower if that's okay with you. Okay? So here's what I want us to do. We're going to start just like we did up here. We started writing the function, but instead of x, I wrote a 2, right? Here, we're going to start writing the function, but instead of x, I'm going to write g of x. So I'm going to write 2 times g of x minus 3. Everybody okay with that? I started writing the function of f, but instead of writing an x, I wrote a g of x. Everybody's with me, right? Except, like he was saying, don't I know g of x? It's x squared plus 5. So now I'm going to write, instead of writing the actual g of x, I'm going to write what I know g of x means. X squared plus 5. Now I just distribute, right? 2 times x squared, 2 times 5. Simplify like terms. Did you get the same thing I did? Good, that's it. No, we're not going to do that on these. Okay? We're not going to find the domain on these. Because here's what we are going to do though. I want you to find g of f of x. Don't look at me like that. What does it want me to do? Instead of writing g of x, it wants me to write g of f of x. So I start writing g, and instead of writing x, I write f of x. So f of x squared plus 5. Do I know f of x? 2x minus 3 squared plus 5. Not if I give it to you like this, no. You'll always know f and g, both of them. Now, if any of you take this and write the next step as 4x squared plus 9, I'm going to beat you. And I put that on the recording for everyone to hear. Because what does it mean for something to be squared? By itself, so I say 2x minus 3 times 2x minus 3 and then plus 5. So what do I actually need to do here? Distribute. What's 2x times 2x? 4x squared. What's 2x minus 3 or times negative 3? Negative 6x. Negative 3 times 2x. Negative 6x. Negative 3 times negative 3. 9. And then plus 5. Now combine like terms. 4x squared. Good. Minus 12x plus 14. Okay so far? So here's the deal. These don't always look like this either. Okay? You know, like how these, they had a different way that we wrote it sometimes? Sometimes this will look like this. And this will look like this. F of g of x, like of, like O for of. F of g of x, g of f of x. So guess what people call this? Fog and Goff. Literally, that's what they call it, fog and Goff. Composition of functions, fog and Goff. Okay? Now, I really, really, really need to show you why composition of functions is so important. Okay? So I'm going to remind you of problem 21 from your homework from last night. It said f of x was negative 3x minus 9, and g of x was negative 1/3 x minus 3. And what you did was take this, switch x and y, and solve for y, and see if it was this, right? So that's the baby way to do it. And there's a lot of places that you can mess up. So instead, to verify that things are inverses, we're going to do Fogg and Goff. And you're going to see what I need or what you need to see. Okay? If I do Fogg, that means I'm starting with f and I'm substituting in g. Okay? So I say negative 3 times. Now, I need to know if you guys are ready for me to skip the step or not. Yes, I can skip the step? Okay, because normally what I would write right here is g of x, right? But we already know what g of x is, so you're telling me I can go ahead and write g of x in there? All right, negative 1/3 x minus 3, and then minus 9. Because I took g and put it into f. Okay? Well, what is negative 3 times negative 1/3? Well, that's negative 3 over negative 3, which is 1, right? So I just have x. What is negative 3 times negative 3? Positive 9, and then I have minus 9. So what does that equal? X. Then I'm done with that part, right? I just stop, okay? You'll understand more in just a second. Let's do Goff first, and then we'll talk. Is that all right? Okay, so let's do Goff. So I start writing g, but I substitute f of x anytime there's an x. So I write negative 1/3 times what? Times f, right? So negative 3x minus 9